Assalamu alaikum. This is me, Khalil Houthi. I would like to show you how you can convert a graphic image like the one we have here to a vector image using Global Mapper. So we have three cases or three maps. We choose the first one. Let's save it as a or export it out of PowerPoint, save it as a new picture. So I bring it here and make a new folder, name the folder Fall 2023. Save it as you see. Then I open the software Global Mapper. Uh, let's wait for the software to launch. Still waiting. Here is it. So let's open the same figure we just saved. You click actually here, open data files. Then you go to the same folder we just created for 2023. Choose the same picture, open it, choose the default here. Okay, okay. Here we need to specify at least 4 points to at least give a projection to what we have in the figure. So this figure is in Oman. So in Oman, we usually use UTM, Universal Transverse Mercator, UTM, and Oman is located at 40 North. So we choose 40 North, and the datum is the one belongs to PDU. It's PDS. So PDS, where is PDS? Let's search for the PDS. Yeah, that's the one. PSD, sorry. PSD Oman. It's belonging to PDU itself. Click OK and I zoom in here. I drag with the left mouse button and release. Drag, press and drag. You can zoom in with your mouse scroller or mouse wheel. Then click here. So you see when I click, uh, I will be prompted with the pixel X and Y location. So pixels usually starting from here, top left. This is 0, 0 going down. The Y number of Y pixels increases going to the right. The number of pixels increases. So we need to specify what is the coordinate here. The coordinate as we read from the figure itself, the x is 525 600, whereas the y is 243 2000. We add it and give it the default name, point 1. Don't look for the error because it's just 1 point. So the errors will be presented here in the last column. So let's choose another point. The next point is in here. So here the x is not changing, whereas the y increased. The y gonna be 800, 2440800 at the point as point 2. You see that there is a lot of error. It's expected that we're gonna have error because we haven't set we have only 2 points, and we see the errors are actually in the x-axis because this is only one x-axis. The x-axis haven't changed, so there is an error. Let's choose another points, a third points. I make it here. So here the y is not changing, the x has changed. It's 5, 3, 7, 600. The y is still the same. Add it, all the errors became 0. Add one more points. So let's add these points. In each corner, we have 1 point. And here the x, sorry, the y, or actually the x hasn't changed, the y has changed. So the y gonna be 243, 2000. 243, 2000. Add it. You can add more if you like. You can add one here, one probably in the middle. So make sure that the projection is correct. UTM zone 40, PSD 93. It's in meter. Click OK. Click OK. So we have the image. It has been converted to a vector image, and we can export it, by the way. So if you go to File, Export, you can export it as a raster. Uh, it's not a real. It does not have the elevation values yet, but we can export it and we can view it in probably, let's say, Google Maps. There are many formats available. So one of the simplest format is the Google Map format. So Google Map accepts actually KML or KMZs. These are the formats which could be opened in Google Maps. We choose KML or KMZ. So again, where did I go? I go to File, Export, Raster Image, choose the default options. Okay, just okay. Let's go to the same location here. Let's name it map base. That's Google Map and save it. So let me open the same folder. It's in here. That's Google Map. I can right away open it, double click. Make sure that you have instead Google Map or Google Mapper or Google Earth. They name it actually Google Earth. Google Earth. Its name is Google Earth. Double click on it to open it. So I'm having Google Earth. Let's see where this location is. Yep, here is it. Here is the location. Let's make it rotated to the north. Perfect. It looks like it's perfect. It's close to a location called Maradi, Safari, Qarn Halam. There is a hospital here, probably. Yeah, it's an oil field. Definitely, it's an oil field. I do have other points, but they are not related to the map we have. Let's double click on the north. Yep, that's the map we have. It's located here. Everything is correct. This is the Salah Arc, Jabal Madmah, Jabal Salah. This is Adam City. So let's go back to the global mapper. So the next step is to digitize the contours. We need to draw. I believe that there are some other softwares I'm not familiar with actually, in which you can automatically digitize those contours. However, I'm not familiar with them. I use Global Mapper, sorry. This software's name is Global Mapper. So let's start digitizing contour by contour. We go digitize, create line features, and if I choose the first option. Okay, so let's go one by one. I discard this one. If you are trying to become more precise, you can follow along this one as well. However, I discarded. I will go start with this one. It's -4620. So let's start clicking. I click with the left mouse and you want to be more precise, make more clicks. And finally, when you want to stop, right click. Here, name it contour. The name is not required, but the feature name is required. Here you need to type something and we add, you can name it whatever. I had already in a different projects. In that project, I had a few names, so I can name it whatever I like. You can name it base, for example, base depth, and that's basically what was the value? 4, 620 minus 4, 620. That's what I'm reading from the map itself. Okay, okay, so I have one feature. Let's go to the next feature. Start doing mapping again. Uh, contour, contour, depth. That's, you have to choose the same name, deep base depth. If it's not available, select it from the options you see here. So we go with the same depth is minus 4 to 40, I believe. Yes, or am I right? Is it 40? I think so. Yes, it's for uh, 40. Yeah, it's increasing. Sorry. It's supposed to be 640. That's what I read from the contours. I click OK. Yeah, definitely. No, I'm wrong. Sorry. Let's edit it. It's uh, it's 0, 0. Yeah, it's increasing negatively. Increasing negatively. So the next one is 580. Yes, update. So we are done with this one. We go to the next line. Let's try to make it faster. For your case, you probably need to be more precise. I type the same value here and I go add, select minus 4, 580. Each time we are incrementing or decrementing by 20 meters. You have three features and they can view their details, edit attributes. That's what you see. So 0, 1, 2, and they are all minus 620, 600. It's increasing positively. So next one is 560. Let's do it very quickly. I stop here, contour, and add the value of the contour, base depth minus 4, 560, I believe. Yeah, yes, that's 60, definitely. Let's make sure it's minus. I probably sometimes forget am I typing my negative or not. Let's move to the next one. You might fast forward my videos or increase the playback speed. Or that's the previous one was 60. This should be 40. Add minus 4, 5, 40. Okay, okay. Let's go to the next one. I will try to make it fast. This is a bit time consuming. Contour, add minus 4, 5, 20, I believe. Okay, so 4, 500 then. Again, my recommendation is that you need to be more precise. You can zoom in, zoom out. You see, I'm a bit off from the actual line, but for your case, try to be more precise. Contour, add minus for 500. Okay, okay. You can press the wheel button and drag like that. Next one, 480, 480. Okay, let's do it. Let's make it a bit fast. Contour, add minus 480. Definitely getting shallower and shallower. What is the next one? Is 60. So this is the next one. Oh, sorry. To zoom in. It is snapping on the old point. Or 460. Contour, I already copied, so I'm just doing paste. Minus for 460. Okay. For 440. Next one stop here. That's minus 440. And sorry, it's supposed to be contour here. Whereas here we add minus 4440. Okay. We are still far away from completion. So you probably need to increase the playback speed of the video if you are watching me and feeling bored doing this repetitive job. They're following along these lines. Is 420. Yeah, contour, add minus 4420, then 4400. Contour is 4400. Okay. I'm done from here. So let's see what's the next. Here am I right now. You probably need to be more precise than what I'm doing. This is 380. The name you read contour here is the name we provided to these features. They are all contour, contour, contour. You can actually provide the same name as the contour value. So the line name will be identical to the value of the contour. But for simplicity, actually, and to be much quicker, I'm just naming them contour, all of them. So probably here you better write 3800. Sorry, 380 for 380, but let's name it contour minus for 380. The next one is 60. So let me move up, or let me continue with the same line, no worries. So this is the next one. It's easier because these lines are continuous lines. There is no pause, there is no break in these lines. So we try to finish first the lower part. Well, almost halfway there. Contour. And here at the same one, it's, I believe, minus 4, 360. Okay, good. Minus 440 next. That's the one. We stop here. Contour. Add depth minus 4, 340. Okay, okay. Done with this one. So you see they are continuous on the other side. We can map them as well here. So I do have again 4 360, 4 380, 4. we should continue them to the other sides. So what I do, I start again from here because it's not continuous. You just need to stop here and continue from the other side. So how you do that? You just follow along the same contour. So when we arrive to a fault, it's better to stop here. I believe this is as well 40, so there is not much offset. The offset is not clear, so I believe it's very safe to continue. This is contour, and the value is minus 4340. Okay, and we can continue with minus 4360. Next, contour, minus 4360. Okay. Uh, I might skip if you want. I might skip minus 4380 and just do this one for simplicity or to be faster. Contour, that's minus 4400. And let's do this one as well. Skip this one, but I ask you, you're following along, draw the line along each contour. So I go here, tour, that's minus 4440. The previous one was 20. Perfect. So let's start along this long line, minus 4320. So we can continue. There is no faults cutting through this contour line. Well, again, I'm on safe side. I think I can continue mapping here. The offset is very subtle. Definitely very long line. Contour, add the line, minus 4320. Okay, so let's go with this one. In case if you have 6 or 7 members in your team, let's each one do probably one map. I think here I can still continue. There is not much offset. However, whenever, for example, for such case, I recommend that you stop For example, here you need, we'll show you again when we arrive to the next line. You see in the lower part there is a mismatch. So here you need probably to stop at the fault, don't continue. You see here, I need to stop along the faults. Contour, that's minus 300. And don't continue. Start again over from here. So if you have a laptop, I recommend you use a mouse. It helps a lot. Especially the mouse wheel helps in terms of zooming into the figure and zooming out. Definitely one of the longest contour lines. Contour, add the value minus 300. Okay, so let's see what's the next. Finished from these. Here is the challenging part. So here we need to be a bit cautious. We cannot continue. We cannot map along these faults. We can start, for example, from here. Try to be more precise. This is 280 minus 4, 280. Sorry to say, I'm recording right now. It's very close to 10 p.m. I arrived to Skiu at 7 a.m. and I was working few things for deadlines. So I believe we need to stop here. We can't continue. It's better to stop along the falls. Right click. That's the value. The value is minus 4 to 80. Okay. And we continue on the other side. The fault. So pardon me if you find that my voice is that I'm a bit tired. There is subtle fault, but looks like it's not cutting through the contour, and it's safe to continue the line. And if whenever you do something wrong with any last click, you can control and Z. Click control and Z. So here it's still continuous. We reached back to the same point, and I think we need to stop here. So again, contour, give it a value of minus 4 to 80. Okay, okay. So the next one is 260. Let's see how much left. Not much. But the inner part is a bit tricky part. Let me do this one. The inner one, this is a closed contour inside. It will be very easy. Finally, right click. Contour, add minus 4 to 60. So if you, for example, give a wrong value, you'll find that there is something wrong with your final map. Here, this is how much? It's the same contour, you see, 4 to 60. Here we do have a wheel. The wheels are scattered in the shallowest part of the reservoir, in the crest of the reservoir. We have also another wheel, 10H2, and I believe these are the same wheel you will be given later on. So I need to stop here. It's the same value, minus 4 to 60. Okay. Okay. And we continue in the other side, lower part. I stop here. Again, the same value, minus 4 to 60. And I continue in this side. So this is a different contour than this one. The adjacent contour in this line is totally different. It's not the same as 260. There is a big offset, or the throw of the fault is becoming larger and larger. Yeah, it's safe to continue. There is a subtle change, but safe to continue. You need to stop here. They are not continuous. I cannot continue along the fault. The fault is not a contour. Minus 4 260. Looks like this was one of the most challenging contours. So let's continue on the other side of the fault. Stop here, contour, add again, minus 4 260. Almost done. 60, then comes 40. Let's start from here. There is a displacement along the fault. The fault is offsetting actually the contour. I mean this fault. You might wonder how they created these faults. They use basically seismic data. This is two 40. So it's safe to continue here. Stop here at the fault. To add minus 4 to 40 to 40 definitely. So here the same one, add minus 4 to 40. Okay, then I haven't mapped it here yet. You see there is a big offset. So let's map it here. We stop along the fault. This is the end of this contour, minus 4 to 40. Let's move to the shallower contour. This is the same. This is the shallowest contour then. 40. Mhm. So this is here we have 4 to 20. So let's map this one. Top here, contour, add minus 4 to 20. Add. There is a fault. I continue on the other side of the fault. Again, they mapped or they created the contour map itself, or the structural map, they name it as well, from seismic data. Will data can be also helpful. They do something called will to seismic tie, through which they create a relationship between seismic data and will data. The purpose is to decrease any uncertainty in the seismic data. Contour, add, that's minus 4220. I'm in the center. Next one is 200. I stop here. You see this contour is different. It's 180. That's the next shallowest contour. So minus 4 to 200. Perfect. Starting again here. There is a big offset. Stopping here to add minus 4 200. Okay, starting again here to minus 4 200. Yes, it's the same one. Contour minus 4 200. In here, this is also minus 2 4 200. contour minus for 200, and this one is 1 is minus 480. Minus 180 again here. Contour minus 1 minus sorry 4 180. Continue it on the other side. Contour this one, sorry again, minus 1 480. That's the last piece. Contour at minus 4 180. So we are done. We went through every contour line. So let's save the project before we proceed. Save workspace, and I save it again here. I name it mapper. I have 43 lines. So what I do, I click on all of them and select all features. Yes, so they were selected. You see the interval between one point and another is not consistent. It's sometimes denser, sometimes a bit sparsely located. Better to do something, increase the number of points, or we make something called interpolation. Yani, we have a point here, another point here. Let's create points along the lines. And how we achieve this? We basically go to digitizers. Um, Again, digitizer, advanced options, views options, I believe. The advanced options, yes, that's the one. Advanced creation options. This is where we go to digitizer and advanced feature creation option. Create points feature spaced along selected feature. That's the option we choose. Create point features spaced along selected features. Yes. And we choose this option. And we say every, let's say, 20 meters or 10 meters. Yes, 10 meters. Let's make it 20. 20 meters. Let's create an extra point. We keep also the original vertexes. These are vertex, the blue points. And we click OK. And let's name it contour again 2. That's the first one is contour 1. This is contour 2. And name this one as will contour 2 and click OK. You see? Wow, so many points. 4,000 points. Yeah, there's so many points. Let's unload this one. Yeah, we have chosen 50. Let's make it 50 meters instead of 20 meters. Unload. Yes. So we are back to the original one. Let's select all these vertices again. Select. Yeah, definitely 20 is very dense. Digitizer. Uh, where is it? Advanced create points. Sample, let's make it 100 meters. I think that's fine. 100 meter is good. Okay, click OK. Contour, contour 2, that's contour 2. Okay, yep, that's good. This is better. You see the points? We have more points right now. Good. So it's time to export it. I disable exporting the other options. Allow export, no. So it became red. I won't need to export picture. I won't need also to export original contour. Let me save it. And I export this one. I go to layers, export. So I select this one, right click, layer, export layers, and export it as CSV, comma separated values. Export, okay. Don't choose the default. Don't make changes. Okay. So that's, I believe, the base points. Save it. So let me open the same file. That's the file base points. It can be opened using Excel, but it's not an Excel file. It's basically a text file. But let's open it with Excel. So what you see these things. So we don't need the elevation. We need definitely X, Y, but we don't need the label. This is the random elevation. We need depth, base depth. That's the attribute we have given to the data. Okay, let's save it. We saved it. And we can open this actually in server. Let me open server. Close. Close this one. Let's create a grid. So the first thing in server is to create a grid data, choose our data or browse our data. Let's go to the same location. This it was in D drive in where is it? Uh, Software probably. Do you see software? Yes, here is it. Yeah, that's the one. All, that's the one. So we have x, y, and depth. X is x, that's true. The x coordinate should align with the x, y should align with the y, and z should be the base depth. Let's go next. Don't make changes here. Or else if you want to make it a bit better using kriging methods, you see, variogram kriging, simple kriging, actually you don't need to know what's the kriging, but this is just a simple adjustment you can make. This is the maximum similarity, the minimum similarity in this direction in terms of depth. Next, these are the points you see. And next, finish. I get a report. That's the report of the grid creation. And I don't need to save it. Oh, don't need to save it. That's fine. No. And let's go home. create a contour. So this is my contour. You see, there is a bit of unsmoothness here. That's the contour I got. It's almost similar to what you have in the original map. And let's color code it. So I select this one, and coordinate system are not necessary, smoothing levels. Let's use color fill instead of in the general, instead of this color scale, I can use another color scale. There is something called geology, probably. Is there geology? Elevation, an interesting color we can see. Exploration, maybe this is not nice. Let's see some smooth color. Orange blue, maybe. Grayscale. Yeah, you can choose whatever you like. I'm not seeing some interesting geology map. Okay, rainbow. Ooh, it's green, red use, that's fine. So the contours are there, everything is there. So there is an option, let's meet, figure out. You can also include what they call more levels. We need a scale. Oh, I can bring a scale here. In general, it's in general probably. Yeah, that's the scale. This is the scale definitely. Let's me try to add to the map. Scale bar. Scale bar is necessary. It means that this is 200 meters. From here to here is 2 kilos. Not 200 meters, 2000 meters. So this is 2 kilos, and total from here to here is 8 kilometers. You see, I was very fast. We were not mapping faults. So here's supposed to be a fault. There is another fault. These faults were not mapped, and that's the reason you see these kinds of interesting or non-geological features. There is a fault definitely here. Here there is some issues. The contours are not very complete. So do you mind just, I'm getting a phone call. I will respond to the phone call very quickly. Hi, guy. Hello. So sorry for pausing. I keep getting a phone call. So that's how is it. So there is an option here. Okay, let me see this feature. And we need to calculate volumes. So here you can do calculation of volumes, volume calculation. That's the feature. You go to the grid. Uh, but the volume calculation is not done through the map itself. This is just a regular map. We need to have a grid. So we choose the grid we created. That's the same grid. And here you need to choose what is the constant value. What do you think is your closing contour? And also you can create a polygon. There are options in here. You can, for example, create a closing polygon, so it does not extend beyond that. So if I choose, for example, this value, let's say minus 4 to 40, and just click, there is no Z vect, no exaggeration, basically, we don't do exaggeration, so this should be 1. There is no lower surface, we use a constant, that's the upper, this is the lower. We click OK, I get this report. This is the report I get. So I get the values, cut volumes. So they use these types of calculation. Total volumes by trapezoidal, by Simpson rule, by Simpson 3 over 8 rules. These are the values. Yeah, you see them negative because server works in negative, but you need to convert them to positives. They should be converted to positive. We are using trapezoidal rule, Simpson's rule. The trapezoidal rule is, where is it? I think I sent it to you today. Calculate. So basically the trapezoidal rule, let me wait for the web page to open. So here I'm showing how to do it in this software server. I probably might also show you how to use Petrel. Here is how the calculation is done. So the area of the shallowest contour here, the area of the deepest, that's this one, divided by 2, plus the area of each enclosing contours between the lowest and the shallowest, or deepest and the shallowest, and all of them multiplied by the contour interval. In our case, this value, the value of D was 20. So here it's explaining us actually the trapezoidal rule. There is also another rule called rhizomoidal formula or rule. And there are other rules as you have seen here, um, Simpson rule, another one. So these are the values. And if you want to calculate the positive, that's how this is the values actually. Total volumes by trapezoidal rules and so on. So let's stop this one. Let's go to server, sorry, Petrel. Petrel, I open Petrel. Petrel takes a bit of time to launch. Hopefully it does not take too much time. Good, I got it working. So let's compare what we see here with what we get from Petrel. So in Petrel, you need to create a new project first of all. Go to File, New Projects. Taking time. Yes. And the first thing we do whenever we create a project, okay, we need to bring data. So import a file and we import the grid data we just created. Where is it? It's CD drive. So what I do, I just click here, import file. That's how it works. Go to see, it's in softwares. Where is software? Software. Okay, then final projects, fall. These are the data. That's what I, hopefully Petrel opens this one. Uh, so I need to select the correct format. It's what kind of data is this? It's just XYZ. Where is XYZ? It's not Prism. The function, literal formats, literal points with attributes. Yeah, maybe we can use this one, literal points with attributes. Yes, let's choose this one. Hopefully it works. Yeah, the first step is to define your coordinate reference system, basically your projection. That's the same thing we did when we initiated Global Mapper. So you will be welcomed with this window, PSD. We just type PSD and we get PSD, we get two. So the one we used there was 40. So you see it's covering Oman. It's covering whole of Oman. Don't use this one, 93. Use 40, 93. Oh, sorry, 39 is shallower or smaller, whereas this is the correct one. Click this one. Okay. So I cannot open this file. Let me copy paste it and change the format. So this is my file again. Let me save it in different formats. Save as. I instead of CSV, I save it as space delimited txt. Txt, not comma delimited. Mm, formatted text. Space delimited. Yes, that's good. We save it in this format, space delimited, PRP, formatted text, space delimited. Save. We can close this one. We can as well close this one. So where is it? That's the one. You can open this one, by the way, in Notepad just once. So that's what you get. I'm using dark theme. That's the reason you see everything is dark. System setting is dark. Let's try it again. Open it. That's the one. Petrol points with attributes. Yeah, I believe that's the right one. Yep. No, it's not the right one. Sorry. It's not the right one. It's not petrol points, or it should be general points, I believe. Do we have general points? Yep, that's the one. General lines points. Yeah, that's the one. General line points ASCII. Choose again the same format. Space delimited. The extension is PRN. Number of headers. There is one header. The first line is a header. It's not the data. The first column definitely is the x-axis, the y column is the y-axis, the third column is actually the z. And these are points, they are not lines. These are all points. Here we see sample of them. It's not complete, it's just showing 30 lines. So make sure that it's points. The first line is the header, it's not the data points. Column 1 is X, column 2 is Y, and the third column is Z. Click OK. Um, it's general depth basically. You can name it base case points, probably. You can rename it or name it whatever you like. And click OK. So we can't view them. If you want to view them in Petrol, you need to create a window. We can view them in 2D windows. So let's create 2D window. These are my data. You see, this is how they look like. And I can view them even in 3D. If I go again, 3D. These are 3D basically. This is how they look like. And I can increase the exaggeration. These are the original points. And I can color them as well based on their elevation. Not getting colored. Maybe points not get colored usually. Anyway, we do have two a map view as well as a 2D window. So this is a map view and a 2D window as well as a 3D window. So what's the next step? We create a surface from our data points. How to create surface? You go to stratigraphy. and make surface. You go to stratigraphy, make surface. See this option? What's your input? That's your input. And, and from where we get the limits, we get the limits from the data. Good. That's it. There are additional parameters you can adjust. But for simplicity, let's make it as it is. And we don't change the algorithms. Let's click on OK. So we obtain a map. That's the map. I can view it in 2D window. So this is my map. And I can play around with it. I can, for example, I can here, I double click on here, double click. I can go to style. I can show contour values, contour annotations, yes. And their font is very small. Let's make it larger, very large. Maybe 200 is good. And they are repeated. So if they are repeated, I can increase the interval to 30,000 instead of 3,000. Yeah, maybe 30,000 is large. Maybe make it 10,000. Yep, good. This is what we get. It's very similar. It's way better than what we received actually in server. So let's me copy it. How I can copy? In Petrol, it's very easy to copy. Control C, Control V. So let's assume my contour is 4275. Let's assume that's my contour. So here is it. This is my surface. Again, I can show the contour values. I do the same thing here as I did in the map view. You just go double click and show the annotation of contours. Yeah, definitely small, maybe 300 is good value, and make this one 1,000, 10,000, sorry, to show fewer number of contour values. Nice, it's very close to what we obtained. And another thing you can play around, if you go here again, contour interval in your case was 20, here it's 25, make it similar to what you have there. So you see the faults have not been mapped. There is a fault, there is another fault, there is one fault as well. Let's assume that my contour is closing at, let's say, what's the value of this contour? Maybe 4 to 80. So I go here, I can rename this one. Let's say it's I go to info, I rename it to spell point, spell point, spell point, apply. So these two are the same, their name is only different. What I can do, I can go again, double click, and there is an operation, it's called operation, select operation, no, sorry, calculation. So you can assign it to a value. We said minus 4 to 80. Whole of this map gonna be one map. So we say Z, whatever Z value we assign, Z value or the depth value of this surface gonna be equal to A. You just click on this one. Okay, so you see it's just one map. If you go to 3D and print them out or show them together, you see it looks like this is the spell point. Maybe it's uh, it's your task to choose the best spell point. You can play around with it. You see which one is closing. So how I can calculate volume right now here? I need to click on this surface. So I double click again. Now, right now, instead of calculation, I go to operation. And in the operation, you'll find there is an option called calculation. Calculate below a constant level. You can choose this one. And here you specify the spell point value. So we said it's 4280. And that's just a guess from my side. Could be a different value, I'm not sure. I'm just quickly trying to finish the video. Click run, and in here you'll find that there is a message log. It spells out, it write down what is the area, total area as well as the volume. That's the volume. This is the volume you get. This is using server. Oh, sorry, Petrol. This is how we get it from Petrol, and I trust Petrol. So here you get the reports. That's it. Interesting. So I end the video here. All the best.